Okay, we continue to learn Chapter 1, Matrices and System of Equations. For elementary matrices, now we learn the third part, Triangular Factorization. An n by n matrix of A is an upper triangular matrix if Aij equals 0 for all I greater than j. This means this part, right? So this is the upper triangular matrix. And a lower triangular matrix if Aij equals 0 for all I smaller than j. Okay, like this. So we can have from the main diagonal entries, and the lower you can have one non-zero entries, but upper must be 0 entries, 0 elements. Okay, a triangular matrix, if it is either upper or lower triangular, so we call it triangular matrix. And we also have the unit triangular matrix. Unit triangular matrix means that for the diagonal entries, they are all 1, then it's a unit triangular matrix. For a linear system, Ax equals b to be in strict triangular form, the coefficient matrix A must be upper triangular with non-zero diagonal entries. This is before we use for strict triangular form. And diagonal matrix, we see this matrix is diagonal if Aij equals 0 whenever I does not equal to j. So for diagonal matrix, we only have the non-zero entries in the diagonal. Okay. A diagonal matrix is both upper triangular and lower triangular. So it's like this. Now we consider about triangular factorization. If an n by n matrix, square matrix A can be reduced to strict upper triangular form using only row operation 3, then A has an LU factorization. That is, A can be written as L times U. We only use row operation 3 to transform A to be a strict upper triangular form. Okay. Row operation 3, we know that it can be represented as an elementary matrix, which is a unit lower triangular. So what does this mean? Because row operation 3 comes from identity matrix by using the row operation, one row operation type 3. So this means you use a scalar alpha times the ith row, then add to the jth row. If you use the I smaller than j, then you will get a lower triangular matrix. And because it comes from identity matrix, of course, it is a unit lower triangular matrix. Okay, and we know that multiplication of lower triangular matrices is still lower triangular. We see example how to get the LU factorization of this matrix A. A equals this one is a 3 by 3 matrix, and then we can factorize it to 2 matrices. The first factor, it is a unit lower triangular matrix, and the second one is upper triangular matrix. So how can we get this? We just use the row operations, only type 3 row operations. Okay, so for example, you need the scalar minus 1 over 2 times the first row, then add to the second row. You will eliminate this one to be 0, right? And you use the scalar minus 2 times the first row, then add to the third row. You can eliminate this 3, 1 entry to be 0. 4 becomes 0 now. So you do, these are 2 elementary matrices of type 3. And then you further do also row elementary matrix of type 2 using this position, this pivot element, to eliminate this one to be 0. After you eliminate this one to be 0, this one to be 0. So these 3 row operations, after you get it, for example, here is minus 1 over 2. So L21 equals here 1 over 2, just the opposite value, just the negative value of the scalar you used before to constitute the type 3 row operation, okay? And also L31 equals 2, also just the negative value of the scalar you use to eliminate this part, this one, to be 0. And similarly, you can have L32 equals minus 3. So you can get this L. And after these row operations, this upper triangular matrix, you can obtain immediately, right? Okay. Now, if an n by n matrix A can be reduced to strict upper triangular form using row operation 3, it can be LU factorized. That is, if there exists type 3 E1, E2 till Ek such that A pre-multiplying these elementary matrices of type 3, which equals an upper triangular matrix, then you can write A equals E1 inverse times Ek minus 1 inverse times Ek inverse times U, and L just be the multiplication of E1 inverse till Ek minus 1 inverse times Ek inverse. And we know this multiplication of unit lower triangular matrices is still a unit lower triangular matrix. So we can get this LU factorization. For example, we know from A, we use 3 type 3 elementary matrices. We use these 3 row operations of type 3, we will get the upper triangular matrix U. And because A can be written as this type, so we know L should be the multiplication of E1 inverse, E2 inverse, and E3 inverse. You can get this one. This is just the unit lower triangular matrix.